The name of our paper is Line and Colorization Matching Feature Transfer Network for Automatic Animation Colorization. This work is led by Aiqi. There are generally 3 steps in animation colorization process. The key frame sketches that define the major character movements are portrayed by lead artists. Then, the in-between sketches of motions are drawn by inexperienced artists. Finally, the labor workers colorize all the line art as a basis of a character's color chart. There are lots of sketch frames to be colorized, generally 20 to 30 frames in 1 second of an animation. This makes the work tedious and labor-intensive. So, in this paper, we try to find the automatic model to do this third step. There are lots of previous works on sketch colorizations. A lot of GAN-based translation methods for single line art coloration has emerged, aiming at generating perceptual pleasing results. However, they don't consider the frame in between consistency. For video, in TCVC, they simply take in the previous color frame as an input to predict the current color frame. The reference color frame is misaligned in spatial with the sketches. We need to find a global correlation between frames to align the reference image. Also, correlation can be found by matching the pre-trained network features, but it is not fit for sparse sketch representations. In order to learn effective sketch features, we design a learnable correlation matching model and integrate it to our generator for training. We model our problem as an analogy. XA, XB has the same content but in different domain A and B. YA, YB has the same content but in different domain A and B. We know XA, YA, YB, and we try to reconstruct unknown XB. In CMFT model, we first multiply features of XA and features of YA to get the dense correlation matrix AA. Then we use the correlation matrix AA to map the color feature of Y to color feature of X by multiplication. We take the output of the estimated features of XB, then we can take the aligned feature as a reference to generator. Here is how we add the CMFT model to our generator. SPCP represents the keyframe sketches and the keyframe color image. SN represents the current sketch. CN is the unknown colored image of SM. The SP and SN are encoded by the ES. The color keyframe CP is encoded by EC. Then the 3 features are input into CMFT to get an estimation of color feature of CN. Then we will add it to the decoder as a reference to the generator. We integrate the CMFT to the generator in a cost-to-find manner. We add the middle output of a pre-trained semantic network DI in a first CMFT to bring more abundant information to the matching process. Another point is that we treat the previous layers upsample result as a color feature of CN to match with the color feature of CP in the current layer. This will help to improve the matching processing and make the higher layer and lower layer matching keep consistent with each other. We use 3 movies for training. We grab the shots of those movies and sample the training frame pairs from the same shot. In order to train the model to handle more diverse and intense frame variations, we design a strategy to extract more differential training pairs from a single shot. We apply a sliding window to every sequence to obtain the frame pairs. We test the model in 7 unseen movies. We compare the metrics in both SSIM and PSMR. We compare our method with TCVC, pixel to pixel, and deep analogy. Our experiments show that our LCMFT can effectively improve the in-between consistency and quality, especially when big and complicated motion occurs.